The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome, ladies and gentlemen. I'm DrAvitech, and in this video, we're going to be solving this very problem. Remember to hit the subscribe button, like this video, and comment. Leave something nice in the comment section. All right, now let's get started with this very problem. It's looking kind of funny. Hold on, let me put this. There's supposed to be a theta here. All right, so we're asked to determine the Fourier series of this function. But the thing is, let's kind of wind back a little bit. Do you think this function is even? Yes, I do. I think this function is even. This is theta squared, or you could call it s squared. So it's even. The interval, is it symmetric? Yes. The interval is from minus pi to pi. So it's also symmetric. So what this means is I only need to find a naught and a sub n. That's the only thing. This function is even, not odd. So I only need to find a naught and a sub n. So let us get started with finding a naught. So a naught is 1 over pi integral from minus pi to pi of f of x dx. If you notice, I did not, listen up, I did not reduce it to say 0 to pi because the function was not split. The function was not split. So assuming it was a piecewise function where there was a split at 0 to pi, I could say let me use that. But since the function is not piecewise, it wasn't split, I'm going to know that. Should I say, okay, it's piecewise within this derivative, but it was not split. It was not split. Now, the thing is this. The only usefulness of me knowing that this is an even function is that I only need to find a naught and a sub n. I don't need to find b sub n. So that's the only usefulness. That's the only benefit here. So let us find this. So this will be 1 over pi, integral from minus pi to pi. My theta, this will give me theta squared. Oh, so this will then become the theta, because everything is with respect to theta, sorry. Everything is with respect to what? Theta. I kind of feel this would, I don't know. I don't know why I feel it will give 0. But let's proceed. Let's proceed. So this will be 1 over pi. Then, if you integrate this, you'll be having theta cubed all over 3. Remember that since you have the power of 2 here, you need to say 2 plus 1 over 2 plus 1. That was why we had this. And then this is from minus pi to pi. This is the funny thing about this. All right. Now, I know that this 3 is a constant, so let me bring it out. So this is 1 over 3 pi. And then this is theta cubed. So anywhere I see theta, I'm going to be putting what? I'm going to be putting pi. So theta cubed. This will then become pi cubed. So this is for the upper limit minus, the lower limit is minus pi cubed. All right, so this is 1 over 3 pi. Now pi cubed is pi cubed minus pi cubed is minus pi cubed. Yeah, minus pi times minus pi times minus pi is minus pi cubed. You could put a bracket if you wish. You could. So this is 1 over 3 pi into, this would then be plus. So this is pi cubed plus pi cubed. So this means I'll be having 1 over 3 pi times 2 pi cubed. Now, this pi cubed can be divided by this very pi you see here. The pi cubed can be divided by this very pi. So this means I'll be having 2 pi squared all over 3. That's what I'm going to be having. Because 1 times 2 will give me 2. Pi cubed over pi is pi squared and then over 3. All right. So that's my a cubed. That's a naught. So let us find a sub n. So a sub n is 1 over pi integral from minus pi to pi of f of s cos nx dx. So this will be 1 over pi. Okay, this is theta. Okay, theta. So this will be minus pi to pi of theta squared cos n theta d theta. All right, since everything is with respect to theta. Now, this will be 1 over pi. Now let's integrate. To integrate this, we're going to use integration by parts. But this guy we see here, this guy you see here, pi squared. Sorry, I say pi, theta squared. So we're going to write theta squared. This is theta squared. Now differentiate theta squared. The first time, you're going to have 2 theta. Differentiate 2 theta, you're going to have 2. Differentiate 2, you're going to get 0. But you don't want to write 0. So this is what you get when you differentiate. The next is for us to integrate. So this is cos n theta. Integrate cos n theta. Integrate cos, we get sine. So this is sine n theta over n, because you must always divide by the derivative of n theta, the angle itself. Now this sine n theta over n, you're going to integrate it for the remaining numbers that we have. So integrate sine here. You're going to be getting minus cos n theta all over. Now, there's an over n here already. This is n theta. So if you should differentiate this n theta, if you differentiate this n theta, you will get n. So n times this n that has been here will be n squared. Now, this guy that is in black again, integrate it again for this one. So this will be times, put your minus. When you integrate cos, you will get sine. So this is sine n theta over this n theta. When you differentiate n theta, you will get n. Now, n times this n squared will give me n cubed. Now, the appropriate sign for this will be plus, minus, plus. And then your limit is minus pi to pi. Now, let's simplify this whole expression. So this is 1 over pi. Then we have theta squared sine n theta divided by n. Minus times minus will give me plus. So this is plus 2 theta cos n theta divided by n squared. Plus times minus is minus 2 sine n theta over n cubed. And this is from minus pi to pi. All right. Now at this point, anywhere we see theta, we're going to be putting our limits, pi and minus pi. That's what we're going to be doing. We're going to be putting our limits, pi and minus pi. But the funny thing is, this is sine. Sine n theta, okay, let me put the pi, since we're putting in pi. So sine n, if you put pi here, this will be sine n pi. Sine n pi is 0. Sine of minus n pi is still 0. So what this tells me is, this will give me 0. This will also give me 0. Because whenever I put the limit of integration into them, the sine part will be giving me 0. So that guy is gone. So this is the only useful guy. This is the only useful one here. This is the only useful one. Okay. Now, since this is the only useful one, let's notice something. 2 is a constant. N squared is a constant. So let's bring them out. So this will be, when 2 comes outside, this will now become 2 over n squared. Then don't forget that there's a pi outside before. And then what will be left to become theta cos n theta. Theta cos n theta from minus pi to pi. All right. Now this will be 2 over n squared pi. Now anywhere we see theta, let's put pi. So this will be pi cos n pi. So this is the upper limit minus. Anywhere we see theta, let's put minus pi. This is minus pi cos of minus n pi. Okay. Now this is 2 over n squared pi. Now, let's see. So this will be pi cos n pi. Minus times minus will give me plus. Then we'll have pi cos. Now, cosine is an even function. So this minus n pi here is still the same as when it's n pi. Remember that for even functions, a negative input will give you the same as a positive input. So if you pick a number n pi, cos of n pi and cos of minus n pi is the same. So this minus does not make a difference. It's just going to be n pi. Now, these two things can add up now. They're exactly the same. They're exactly the same. So when you add them up, you get double of it. So this will be 2 over n squared pi times, when you add these two things up, you have 2 pi cos n pi. So this pi will cancel out this pi. So what will be left will become 2 times 2, that's 4, over n squared cosine of n pi. Now cosine of n pi has a special value. So this is 4 over n squared. Cosine of n pi is minus 1 to the power of n. That's what cosine of n pi is. So this is the special value for it. All right. So I have, let me write a naught. So I have my a naught here. That's the 0th coefficient as 2 pi squared over 3. Then I have my a sub n as 4 over n squared into minus 1 to the power of n. So let's get the Fourier series expansion of this. So f of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx. That's what it is. Now, let us put in our a naught. So a naught is 2 pi squared over 3. So that's 2 pi squared over 3. Now, since there's an over 2 here, let me just put times 2. And then plus the sum from n equal to 1 to infinity of a sub n is this. So that's 4 over n squared into minus 1 to the power of n. And then cos n theta. Yeah, remember that our function is with respect to theta. So let me put f theta here. How it's supposed to be. Now 2 we cancel out 2. So f theta is equal to pi squared over 3 plus this 4 here is a constant. So let's bring out the 4. So this is 4 with the sum from n equal to 1 to infinity. What will be remaining if this 4 goes? You'll be having minus 1 to the power of n over n squared cos n theta. Okay, so this will be your answer. If they said in terms of n, leave it, this will be your answer. But let's expand this further. So this is f of theta, pi squared over 3 plus 4. Let's expand this. So let n equal to 1. If n is equal to 1, minus 1 to the power of 1 is negative. So you have minus 1 over 1 squared is 1. So everything will just be minus. So this is minus 1 cos theta. Because when you say 1 theta here, it's going to be just theta. Next is 2. But minus 1 raised to the power of 2 is positive. So this will be plus 1 over 2 squared cos 2 theta. Next, we're going to have minus 1 over 3 squared cos 3 theta. Because I believe by now you now know that if the number is odd, you have negative. If the number is even, you have positive. So next, we have plus 1 over 4 squared cos 4 theta minus 1 over 5 squared cos 5 theta. So this will be the Fourier series expansion of this very function. So this is the Fourier series. This is our answer. So with this, we can call this the end to the video. We can call this the end to this video. And I'll see you in the next one. But let me see. Can I deduce the series pi squared over 6 from this? I think I can. The reason I can deduce the series pi squared over 6 is I know what the series pi squared over 6 is. I kind of know what it is. So I'm trying to see, because I kind of have it here. This is 1. This is 1 over 2 squared, 1 over 3 squared, 1 over 4 squared, 1 over 5 squared. And pi squared over 6 is the sum of these numbers I've just listed. So is there a way I can remove this cosine? Not only remove it, but every part that has minus, let it become positive. Every part that has minus, let it be plus. The only way is for this cosine here to be negative. So this cosine here, it can be negative if I say let theta be pi. Because I know that for every odd value is negative. For every odd value is negative. So the only way for me to make it to be positive is if I make this to be pi. If this is pi, all of the odd will become positive, while the positive will remain positive. So let theta equal to pi. Now remember that f of theta, to start with, f of theta on a normal day was equal to what? Theta squared. So you can say theta squared is equal pi squared over 3 plus 4 into minus 1 cos pi plus 1 over 2 squared cos 2 pi minus 1 over 3 squared cos 3 pi plus 1 over 4 squared cos 4 pi minus 1 over 5 squared cos 5 pi. And then just like that. Now, we said let theta be pi, so put the same pi here. So this will be pi squared equal pi squared over 3 plus 4 into, now cosine of pi is negative, so it's minus 1. Minus 1 times minus 1 is plus. Cosine of 2 pi is 1. 1 times anything is that same thing, so this is plus 1 over 2 squared. Cosine of 3 pi is minus 1. Minus 1 times this minus will give me plus. So this is plus 1 over 3 squared. Cosine of 4 pi is plus 1. Plus 1 times this will give me plus 1 over 4 squared. This one will be plus 1 over 5 squared. And then just like that. Now, I want to pick this guy to this other side. So I want to take this over. So this will be pi squared minus pi squared over 3 equal to 4 into all of this. So this is 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared over 1 over 5 squared. Okay. Now, if you subtract this, you'll be getting 2 pi squared all over 3. Let's do it here. So you have pi squared minus pi squared over 3. The LCM is 3 when you put over 1 here. 3 divided by 1 is 3. 3 times pi squared is 3 pi squared. Minus 3 over 3 is 1. 1 times pi squared is pi squared. 3 pi squared minus pi squared is 2 pi squared. And that's over 3. That's how I got that. Equal to 4 into 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared, and then just like that. Now, I need only this bracket, so I have to divide by 4. So to divide by 4, I'll say over 4 here, and then this 3 will be 3 times 4. Because I'm dividing by 4. Already there was a division by 3. So the division by 4 will just come and meet that 3. Now 2 here is 1, 2 into 4 is 2. So what will be left at the top will be pi squared over, at the bottom, 3 times 2 is 6. Equal to 4, we cancel out 4. So this is 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared. Just like that. And with this, we've been able to deduce this series. A better way to write this series is pi squared over 6 is equal the sum from n equal to 1 to infinity of 1 over n squared. But oftentimes, for Nigerian students, they prefer to just write it like this. So this will be the end of this very video, and I'll see you guys in the next one. Remember, keep on watching, keep on sharing, keep on liking, and keep on subscribing. Tell someone to tell someone about this channel. I'll see you in the next video. Bye.